Hello everyone, this is Dharmendra Reddy, MS 20. Introduction to solar air collectors. Solar air collectors are a type of renewable energy technology that harness the power of the sun to heat air. These systems use dark colored absorber plates to capture solar radiation and transfer the heat to the surrounding area, which can then be circulated through a building from space heating or other applications. How solar air collectors work? Solar air collectors harness the power of the sun to heat air, which is then circulated through a building to provide warmth. The collector's black surface absorbs solar radiation through the air inside. Fans or natural convection move the heated air throughout ducts, warming the interior spaces. The key components are the air intake, solar absorbing surfaces, and air distribution system. Advanced designs may include thermal storage to store heat for use at night or on a cloudy days. Benefits of solar air collectors. Improved energy efficiency. Solar air collectors enhance energy efficiency by directly harnessing the sun radiance heat to warm indoor spaces, reducing the need for traditional heating systems. Lower energy costs. By offsetting the use of fossil fuels, solar air collectors can significantly reduce heating bills and provide long-term cost savings from homeowners and businesses. Renewable and clean energy. Solar air collectors harnesses a renewable energy emission-free energy source, the sun, making them an environmental friendly through heating solution from that reduce carbon footprints. Types of solar collectors. Flat plate collectors. These are the most common type with an absorber plate that heats up which is then circulated through the home. Transparent collectors, also known as solar walls. These have a per- perforated absorber surface that heats up air as it passes through. They are heated collectors. This use a dark colored surface to absorb heat, which is then transferred to air following through the system. Components of the solar air collector. A solar air collector consists of several key components, including an absorber plate, a glazing or a transparent cover, an isolation layer, and an airflow channel. The absorber plate, often made through metal, converts solar radiation into heat, which is then transformed to the air flowing through the collector. The glazing, typically glasses or a transparent plastic, allows sunlight to pass through while reducing heat loss. Insulation behind the absorber plate minimizes heat transfer to the building exterior, maximizing the energy collected. The airflow channel guides the heated air from the collector to the desired space. Choosing and designing a solar air collector. There are three stages of collecting and designing a solar air collector. Determining heat load. Calculate the heat requirements based on building size and climate. Select collector size. Choose collector dimensions to match heat load and available space. Design airflow. Optimize duct size and fan capacity for efficient air circulation. Properly sizing and designing a solar air collector is crucial for maximizing its efficiency and effectiveness. The first step is to determine the total heating load, factoring in the size of the building and local climate conditions. Next, select a collector size that can meet this load within the available installation space. Finally, design the airflow system, including dimensions and fan specifications to ensure even air circulation throughout the collector. Installation considerations. First, site evaluation. Assess the building orientation, sun exposure, and potential obstructions to determine the optimal placement for the solar air collector. And next, mounting options. Solar air collectors can be roof mounted, wall mounted, or ground mounted. depending on the available space and structural considerations. And airflow optimization. Ensure proper ductwork and airflow pathways to efficiently distribute the heated air throughout the building. Electrical integration. Connect the collectors, bolts, or fans to the building electrical system considering the power requirements and safety protocols. Maintenance and troubleshooting. Cleaning. Regular cleaning the solar air collector surface to remove dirt, debris, and dust buildup. This ensures optimal light absorption and airflow. Inspections. Visually inspect the collectors for any cracks, leaks, or damage to the casing, glazing, or air ducts. Address issues promptly to maintain efficiency. Airflow checks. Ensure the air intake and outlet vents are unobstructed to allow for proper air circulation, monitor blowers performance, and clean or replace filters as needed. Troubleshooting. If the system is not performing as expected, check for airflow issues, sensor malfunctions, or electrical problems. Consult the manufacturer's guidelines for specific troubleshooting steps. Applications of solar air collectors. Solar air collectors have a wide range of applications from residential and commercial heating to agriculture and industrial processes. They can be used to preheat air for building, dry crops, and grains and provide ventilation and space in heating in greenhouse. These versatile systems can also be integrated into ventilation and conditioning HVAC systems, reducing the load on traditional heating and cooling equipment and lowering energy costs. And we come to conclusion and future outlook. Solar air collectors have demonstrated their potential as a clean, renewable heating solution. As the technology continues to evolve, we can expect to see future advancements in efficiency, affordability, and integration with other renewable energy systems. The future outlook is bright, with growing adoption driven by environmental awareness and the pursuit of sustainable energy